Hi, in this video we're going to be talking about fixture unit counts in the domestic systems. Once again, fixture units come from the plumbing code, and based upon if you're the International Plumbing Code or Uniform Plumbing Code, you may have different values for those. So I'm going to show you how to use that information for sizing the pipe and how to edit that information if you have a different case than what we've set up, which is based upon the IPC. So this is the sample project. Once again, this is a domestic water riser diagram. And as you can see, we're getting GPMs all the way back to the water service. And we also have fixture units. So now first off, how do you modify your fixture unit values if you need to change them? We have a design schedule, which is actually included on the plumbing schedules sheet. I'm going to open that up. And this schedule down here is placed on this sheet because a lot of jurisdictions like to see this type of information. What are the fixture units throughout this building? You know, a lot of times fixture units will determine your permitting costs. So that's why they like to see it. This schedule is summarizing all the waste, cold water, and hot water fixture units for each of the fixtures placed in the sample project. So a couple things about this schedule. One is that we are not itemizing every instance. So in the case of cold water fixture units here, for this water closet, we cannot change that because it's a calculated value, it's a calculated total. If we wanted to change some of these values, the best way to do it is at the fixture itself. So I'm going to close this schedule. We're going to go back to our riser diagram. So here's a two-story stacked bathroom group with some water closets. If these water closets needed to be a different fixture unit value, and this, I guess I should clarify, this does not apply to overrides that are used in the UPC, where the first water closet is at 40 fixture units, the second one is at 30, and so on. We'll talk about that later on in the domestic fixture families. But if you just wanted to change the type fixture unit value without any override, you'd select the family, you'd go to edit type, and you would come down to cold water fixture units, and you would change it to whatever you needed it to be per code. So changing this here will update all the fixture units in the piping network. It'll also update the fixture units in that summary schedule. I'll give that one more moment. Okay, so now everything's updated here. Our tags have updated. Now the other thing with sizing domestic systems, you can size it off of fixture units or you can size it off of velocity. So in order to get to velocity, you need to determine GPM in the pipe. Revit does include calculations to determine the GPM from the fixture units, and you just have to make sure that your piping system is set up correctly. So in this case, let's activate the overall riser diagram here. We have 44.8 GPM in this pipe, and this is a P_ cold water piping system. So let's go and look at that piping system and see what our options are for calculating GPM. All right, so piping systems, cold water. So right here is how Revit does it, which follows the IPC format. For each piping system, you can choose whether it's predominantly flush tanks or predominantly flush valves. So if we change it to flush valves, we hit apply. As you would expect, the GPM is going to increase. So this is all only possible in knowing that you have the correct amount of fixture units in the system. So now we can use Revit's pipe sizing tools that are embedded to size this pipe based upon velocity or pressure drop, whatever design your firm follows. And that is fixture unit counts.